Welcome back to Code Orbit, and this is day 18 of doing code sources till we reach the Grandmaster level. So in this series, we have already done 17 days, and now I think it's time we increase the level bit by bit. So today we have a problem called the minimum difficulty. As the difficulty raises, so is the question. So here's the problem, and you can see that various things are given here and there. Now, what I'm going to do, guys, is I will just explain to you the problem in short. So, there is a rock climber. Let's say this is a mountain, okay, and he is climbing it, okay, and there are some holes on this mountain. Let's say hole number one is here, then here, then here, and then here. So, what he does is he uses this to climb the mountain. And now, uh, we are given that these are at some height, okay, so these are at some height from the ground. 1 minute. Yeah, so these are at some height, and these height will be given to us like ai plus 1. So yeah, heights will be given to us, and what he wants to do is, let's say, first of all we will given how many holes are there, okay. Let's say there are n holes, n is equal to, let's say, 4. Okay. And like here we have 1, 4, 6. And remember, guys, the holes will all be in increasing order because height is increasing. Yeah, right. Heights will be increasing, not decreasing. So let's n is equal to 4, and we will be given the holes distance. At what distance they are from the ground. Um, let's say this is a wall. So the first hold, or let's say hook, is here, and it is at let's say 1 meter. The second one is here, and let's suppose it is at what you say, 3 meter. Third one is here, and we can take it here. This is at, I will say, 5 meter, and the final one is here. Okay, and this is, let's say, at 8 meters. Okay, so we will be given like this: 1, 3, 5, and 8. And now we are given that the first hold and the last hold can't move. Okay, they are fixed. So you need to fix first and last hold. Fix. Now, what he's trying to do is he will calculate the difficulty between each hold. Let's say difficulty, and how is difficulty calculated? Let's say what is the difficulty between the hold which is at 1 meter and 3 meters. So difficulty is calculated by 3 minus 1, that is 2. So difficulty is 2, which means a of I plus 1 minus a of I. Okay, so this is how difficulty is calculated. And what he wants to do is remove one hold at a time. Let's say he removes this one. Okay, and remember, guys, the first and last can't be moved. So when he removes this, earlier the difficulties were, let's write it down, 1, 3, 5, 8. Not the difficulty between each hold is, let's say, 3 minus 1 is equal to 2. Then 5 minus 3 is equal to 2. And then 8 minus 5 is equal to 3. So you can see the maximum difficulty here is 3. Okay. And now after removing one hold, 1, 3, 5, 8, the 3 is removed. 1, 5, 8. Now the difficulties are 5 minus 1, 4, then 8 minus 5, that is 3. So here max difficulty is 4. So yeah, we just calculate difficulties adjacent of each hole, let's say after removing. And now, since we have already removed 3, now we will remove 5 instead. Okay. So now we will have 1, 3, 8. Now the difficulties are as follows. 3 minus 1 is 2 and 8 minus 3 is equal to 5. And here maximum difficulty is 5. Now, guys, what we want to do is uh, you can, let's say, an array or anything of all these difficulties. Let's see, like here the maximum difficulty was 3, then 4, and then 5. Okay, so we have 3, 4, and 5. These are the maximum difficulties, after removing uh, one block, you can say, or one hold separately. And now what we need to output is the minimum of these difficulties. Like what is the minimum of the minimum possible of maximum difficulties? That is equal to 3. So now let's take an example and show you guys. Now let's take this one, okay? 5, or let's say, take this one. 5, 1, 2, 3, 7, 8. So we have n is equal to 5, 1, 2, 3, 7, 8. Okay. Now, in normal case, the difficulties are 2 minus 1 is 1, 3 minus 2 is 1, 7 minus 3 is equal to 4, and 8 minus 7 is equal to 1. Now, here maximum difficulty is 4. Okay. Now we remove elements. Let's say 1 and we remove 2. Okay. 1, 3, 7, 8. Now, here the difficulties are 3 minus 1 is 2, 7 minus 3 is equal to 4, and 8 minus 7 is equal to 1. Now here also maximum difficulty is 4. Then we remove 3, 1 through 7, 8. And remember guys, you don't need to take this one because we need to give the minimum of after removing the hold. This was just so you guys can understand, okay? Now 1 to 7, 8. Now the difficulties are 2 minus 1 is 1. 7 minus 2 is equal to 5. And 8 minus 7 is equal to 1. Now you can see here maximum difficulty is equal to 5. And now you can remove one more since you can't remove the last. 1, 2, 3, 7 can be removed, and 8. So here the difficulties are 3 minus 2 is also equal to 1, and 8 minus 3 is equal to 5. So here also maximum is equal to 5. Now you guys can see we have three values of maximum: 4, 5, and then also 5. And here let's set right 4, 5, and 5. Now we need to output the minimum of these values, minimum of the maximum difficulties. So that is 4. And you guys can see here the output is 4. So um, how do we actually apply this logic? So you guys should notice, let's say from the above example, 1, 2, 3, 7, 8. When we remove this element, let's say this is the ith element. Okay. Now, what the difficulties become is ith element is removed. So previously the difficulties were, you can say, A of I minus A of I minus 1. But now after it is removed, it becomes A of I plus 1 minus A of I minus 1. Here you can see this and this, I plus 1 and I minus 1. So yeah, after one block is removed, the difficulty becomes this. So we need to apply this logic. Okay, guys. And yeah, so now I will explain on the coding part here. Let's say first we will take the number of folds. Now we will create a vector, or you can say array of this, and let's take the input. Okay, and now guys, we'll create an answer variable, and let's randomly assign it anything. For now, I will, since we need to get a minimum value, I will assign it the maximum possible value. Okay, uh, very large max value. Okay, and now we'll start our loop. And remember, guys, since the first and last places are fixed, we'll start our array from 1, not from 0, because we don't need to check for 0 because they are fixed. And will go not up to n minus 1. Okay. Oops. Now, here we will take a max value which will have maximum difficulty for each combination. Okay. And now we'll create another J loop. And J will also start from 1 because guys, when we will remove, let's say 1, 3, 5, 8, our loop starts from here, the ith loop. And since it is removed, the J will start from here. Okay. And J goes up to n. Now, here is an important condition, guys. Like if J is equal to I, like uh, if we are like for this 3 1, okay, sorry, J will also start from here. I'm sorry. Yeah, 1, 3, 5, 8. This one we start from, so J will also start from here. Now, since J is equal to I, remember guys, this was the condition for the difference. And we will do is we will assign our max value, the maximum of this max and A of, but since we are checking for J plus 1 minus A of J minus 1, A of J minus 1. Okay, and else we can simply say else. Um, Let me just move it here. Else the max value is the maximum of max and A of J minus A of J minus 1. And after all of this, you guys know all of this loop is done. Answer will be the minimum of answer and max. Oh, and I think we need to move it up here. Okay, yeah. because max is defined here. So here what it does is reset answer to minimum possible of maximum difficulty. Okay, and now finally, guys, what we are gonna do is output our answer. And yeah, so this was, I think, it. And let's check whether we have successfully solved this or not. And output is, I guess, 4. Let's run it, guys. Okay, so this one is passed. Let's check for just 3 for just three values. Output is 4. I think 5. Oh, sorry, because 4 is removed. Yeah, this also passed. So I will copy this whole code and we will submit it now. I don't think there is any overflow scenario in this, but yeah, let's submit it, guys, and see. Okay, okay, it's running. So yeah, guys, the main while it runs, the main concept was that if you have removed an element, you need to check the maximum difficulty for the element ahead and the element behind it. Otherwise, just you can check from by the usual method. Okay, yeah. So this was the core of the problem. I will just star mark it. Uh, A of j plus 1 minus A of j minus 1. This was the core concept of it, guys. And now let's see. Yeah, guys, you can see that it was accepted. And so, guys, this was it for day 18 of doing code courses. And I'll try to generally increase the level as to, challenge myself also. But yeah, we'll do it gradually but surely. Okay, so thank you guys for watching and bye bye.